Hi students, good morning. This is Harsana Shukla and today in class 12 we are going to discuss composition of functions. Composition of two functions. We had already discussed in last lecture types of function, that is one function, on-to function, one and on-to, and we had to discuss some questions also. So today, after composition of two function and invertible function, we shall discuss some more questions based on this particular topic. So first of all, write down composition of two function. Composition of two function. See, let f from a to b and g from b to c be two functions, then composition of f and g is denoted by f composition of g. Be careful. This is written g of f, but in composition we write always from the back side, that is f composition of g, and is defined as by f composition g, and is defined as f composition g of g from a to c. That is f composition g of x is nothing but g of fx. Okay, so note it down, this definition. Okay, you may complete this one. Now some theorem based on this. If f from a to b, theorem, if f from a to b and g from b to c, are one onto function, are one and onto function, are one onto function, then f composition g from a to c is also one and onto function. Okay, so let us see. If f from a to b and g from b to c, these are the one and onto function, then f composition of g from a to c is also one and onto function. So for one we must have, maybe you mention it. Now see, for each x1 x2 belongs to a, f composition g of x1 is equals to f composition g of x2. So this is g of fx1 and g of fx2. As you know, g is also 1. That's why this is fx1 is equals to fx2. Okay, and you know very well f is also 1. So this is nothing but x1 is equal to x2. So for each x1 x2 belongs to a, we have to show f composition g of x1 is equals to f composition g of x2. It must implies x1 is equals to x2. Hence, f composition g is 1 function. 1 function. Please note it down. Okay, so you may be completed now. Onto of the bijection of the subjection of the composition function. For each y belongs to B, there exists and z belongs to C such that g f of y is equals to z. F of y is equals to g of y is equals to z. Now, for each x belongs to A, there exists y belongs to B such that f of x is equals to y. Okay? So this can be written as, suppose this is 1, this is 2, from 1 and 2. At the place of y we can write fx, this is z. So this is nothing but a composition g of x is equal to z. Hence, this is surjective. Hence, f composition g is what? Onto function. Okay? So note it down. Okay, now inverse of function, or you can say invertible function. First of all, inverse of function. Inverse of a function. F from A to B is a function, then inverse of f is denoted by f inverse and is defined as f inverse from B to A such that f inverse of y is equals to x. Always remember this thing, okay? Inverse of function. What is inverse of function? If f from A to B and g from B to A, then g is called inverse of f. Or in the simple manner, f from A to B a function, then inverse of f is denoted by f inverse and is defined as f inverse from B to A such that f inverse y is equals to x. Now, how to prove to be a function is invertible. That means invertible function. Okay? So note it down. How to prove the given function is invertible function. Okay? This is a very important question. How to prove the given function is invertible function? If f is invertible, then f must be 1 1 on 2. This is the first method. Okay? Now second one, if f and g are two functions, then g is called inverse of A f if f composition g equal to g composition f. This is an identity function. That is, f composition g of x is x, but g composition of f of y is y. Then this is called invertible function. Okay? So note it down. Then we shall discuss some question based on this. Okay? So note down. Okay, now the questions. This is of CBSE 2015. Okay, prove that let f from n to r be a function defined as let f from n to r be a function defined as fx is equals to 4x square plus 12x plus 15 show that f from n to s so that f from n to s where s is the range of f, where s is the range of f is invertible, also find inverse of f, is invertible, also find inverse of f. Okay, so first of all note down the question. Okay, again I repeat the question. F from n to r defined by the function defined as the fx is equal to 4x square plus 12x plus 15. Show that the function f from n to s, where s is the range of f, is invertible function, also find inverse of f. So first of all, we have to show this is the invertible function. For invertible function, we must have to find f is 1 1 and on 2, or we can find the inverse of g, inverse of f as a g, and f composition of g and g composition of f is an identity function. So first method. So fx is equals to what? 4x square plus 12x plus 15. Actually, this is y, and if we find the value of x, then this is f inverse y. So y is equals to 4x square plus 12x plus 15, and this is nothing but y 2x whole square a square, that is 2 into ab, 2x into 3, 2 to the 4th is a 12, plus 9 plus 6. Now you see, this is nothing but a completing square method. We have to complete this square, because without this we cannot represent x in terms of y. And if you represent x in terms of y, that is nothing but inverse of the function. Why? Because if y is equal to fx, then x is nothing but f inverse of y. Okay? So, first of all, we represent it in the form of x. So, y minus 6 is equal to 2x plus 3 whole square. So, 2x plus 3 is nothing but root of y minus 6. So, 2x is nothing but root of y minus 6 minus 3. So x is nothing but root of y minus 6 minus 3 divided by 2, and this is nothing but f inverse of y. That means this is the f inverse y. Okay, this is the inverse of the function. And if you want, you can write f inverse x. So f inverse x is nothing but x minus 6 minus 3 upon 2. So note it down. This is the method to find the inverse of function. Note it down. Okay, you may complete it. Now see, we find F composition as F composition G of X. This is G of Fx. And what is Fx? Fx is nothing but 12x square G of 4x square plus 12x plus 15, and you know G of y, that is, this is inverse. G is the inverse now. So G of this much means root of y. At the place of y, this is 4x square plus 12x plus 15 minus 3 minus 6 and minus of 3 divided by 2. Okay, and now this is nothing but 15 minus 6 9, so 2x plus 3 minus 3 divided by 2, and this is 2x upon 2. This is it. So F composition G of X is nothing but X. Okay, that means IN you can say I natural number. Okay. Similarly, we can find G composition of F. Okay, this must be Y. Then you can say F composition of G, X is equals to X, and G composition of F, Y is Y. That's why this is an invertible function. Okay, so note it down first. Okay, now see G composition of Fy. G composition of Fy. This is nothing but F of Gx, and you know Gx is what? F of root of y minus 6 minus 3 divided by 2. This is the Gx. Gy. Okay, and then F of this. Now this is nothing but 4x square. X means this one, y minus 6 minus 3 by 2 whole square plus 12x, that means this root of y minus 6 minus 3 divided by 2 and plus 15. Now this is your homework that you can solve it, and you will must get this is y. So what we can do here, F composition G of X is equals to X and G composition F of Y is equals to Y, and hence from this we can say this is the invertible function. This is an invertible function. Now what about the second method? Second method is nothing but you have to show this given function is 1 1 as well as on 2, then you can say this particular function is invertible function. Okay, so I hope you understand all these things. So in next lecture we shall discuss binary operation, because in about the function all topics are over. But if you have any doubt, you can send me comments that this particular question you need to ask, then I have to give you solution. So thank you.